Welcome, my name is Nicholas Oliver. This is XNB272, Assessment Item 3, the Biomechanical Analysis. This is my table of content. For the biomechanical analysis, I chose the block starts in track and field, which is often seen in races 400 meters and below. The biomechanical goal of a track start is to maximize the horizontal acceleration in the shortest time frame possible from the moment the axis exits the block to reaching the maximum sprint velocity. The means in which an athlete achieves this is by producing maximum possible horizontal impulse during the exit of the block, and through the initial steps, he rapidly accelerates his body towards maximum sprint velocity in the shortest distance and time. Often this phase of the skill is characterized between the entering the block, exiting the block, and the initial 5 meters after leaving the block. This here is my deterministic model. The first qualitative feature I chose to analyze today was the triple extension sequencing during initial strides. I chose to analyze this factor because when properly sequenced, near simultaneous triple extension equates to a higher efficiency in force transfer through kinetic chains, supporting resultant force generated being horizontally directed. Additionally, studies conducted by the likes of Nagahara et al. In 2018 and Bezodis et al. In 2019 support a connection between efficient sequencing of ankle, knee, and hip to increase in propulsive impulse and overall horizontal velocity. The second qualitative feature I chose to analyze today was the body position and center of mass alignment relative to the start line. In a nutshell, this refers to the way the athlete orientates his body relative to the starting line and towards the blocks, which means the way he's positioned and the way his body is oriented, either shifting forwards or backwards. I chose this factor because body position and center of mass alignment determines the direction, either horizontal or vertical, in which the applied ground reaction forces are applied. Poor alignment, in this case, generates higher vertical impulse, becoming suboptimal as the goal is higher horizontal impulse. Alternately, it could also increase the time getting off the blocks, as the athlete would need to overcorrect center of mass displacement, going backwards, to generate higher horizontal impulsive force. The first quantitative feature I chose to analyze today was also the correlation between factors such as time between steps, step ground contact time, and step length. This mainly affects the transition period off the blocks, shifting see a shift in the running technique from the forward leaning position to a more upright posture. Due to this shift in technique, there occurs increase in horizontal velocity and the propulsive force of the steps. This is reflected in the increase of steps distance as the participant approaches maximum velocity. Therefore, a negative relationship also occurs at the same time. As the distance between steps increases, the ground contact time and the time between steps also decreases. This negative relationship is supported by current literature as seen in the works by Slawinski and colleagues in 2010, when they compared the rate of force development between elite and well-trained sprinters. Further literature supporting this is Bises et al. In 2021, where they conducted a study on elite sprinters, which they highlighted as well the negative correlation of those factors, and also Hogan et al. In 2019, where they identified the novices/inexperienced individuals don't always follow this negative trend, indicating that suboptimal pulse generation during early acceleration phase. The second quantitative feature I chose to analyze was trunk inclination angle during the block exit phase. This is the angle between the individual's horizontal plane and the longitudinal axis of the trunk, shoulders to hip, at the frame in which neither the feet are in contact with the block. This is important to me as it allows us to quantify forward lean of a participant during the block exit. As we said before, orientation of inclination acts as a good indicator to identify which direction the forces are being applied to. Lower angle of inclination tends to result in a higher horizontal force impulse, while straighter inclination results in a more upright impulse force. Current research indicates that optimal trunk inclination angle during the block exit and early acceleration ranges from 35 to 45 degrees, depending on the individualized physiological compositions, like limb lengths, and the overall participant should aim to stay within the range. Observing performance. We took some filming considerations when we had to analyze our biomechanics. Because we had limited spaces in which we could film, we had to adapt to that. Here in the photo we can see an example of that place, and then and on the side are some of the ways in which we had to, or some of the factors that affected our ability to film those days, including temperature, light of day, the inclusion of boundaries and marks, and the ability for us to even use a competition block that was accurate to a competition standard. In order to participate our participants for the analysis, we made them follow a generalized warm-up procedure to ensure that they were warmed up and that they wouldn't perform, and then the performance would be more representative of an actual race. They were also instructed to wear bright and contrasting colors to the background, so that allows the data gathered in the videos to be more accurate. Participants were also marked using red stickers in key body segments, which around the joints, which would ensure the points remain the same when measuring data in Canovia. The image aside is an example of what that looked like. Because we had multiple attempts on the actual final attempt, the participant was actually quite a bit fatigued. Okay, the 10 faults and weaknesses on the participant's performance. In terms of triple extension, as we talked beforehand, it talks about how your body segments, the hip, knee, and ankle, work together in order to produce maximum force impulse. And in the first picture here, we can see that is the less ideal use of a triple extension, as the extension of the limbs doesn't occur at the same time, which would reduce that impulse propulsion. However, we can see that in the second and third photos, it's much better use of the kinetic chain. So this could signify that the exit off the blocks wasn't as smooth, and therefore the first step wasn't good compared to the later ones. Body position and center of mass alignment relative to the start line. So in the video here, we can see that the participant shifts back a bit, creating a swinging motion backwards, which seems to have an effect on her performance, exiting the block. Other than that, the participant's center of mass it was shown to be too far back, which caused the body to shift back. Compared to an elite sprinter, the center of mass should be closer to the start line, and their arms should be remaining perpendicular to the ground, and head slightly over the starting line. Comparatively, when an elite sprinter exits the block, they exit a more forward trajectory. Here's just a comparison about the factors we were talking about between a professional and a novice. Regarding first steps in negative correlation, utilizing video analysis like softwares like Canovia and manual calculation, I was able to calculate the length of the steps, the length of the steps, the time between the steps, and the ground contact time of each step. In turn, this allowed us to ascertain if the negative correlation between these participants' increase in step length and the step timing were actually there. Here in the slide, you can see that we recorded the data, and we have this negative correlation between both the step length and ground contact time, and step length versus step time. This data trend suggests that the negative correlation was present, and which reflects a typical acceleration pattern shown in elite athletes and elite sprinters in the field, as is highlighted in the literature by Bias et al. In 2021 and Slabinski et al. In 2010, which is a good indicator that the participants' performance wasn't as bad as they originally thought. Trunk inclination angle during block exit phase. The results we got here was that the trunk inclination begins quite low, most likely due to the posture, drop shoulders, and arch back. At the end of the exit phase, the inclination reaches around 60 degrees. So it goes from around 17 degrees to 60 degrees, a bit too high above that end that we talked about. As remember, the literature stipulated around 35 to 45 degrees angle being optimal. One of the reasons why this could have happened was that, as we saw beforehand, we had a bit of a swing motion exiting the block, which could have caused a upshift imbalance and would have caused the athlete to have to overcorrect his motion. Here's a few strategies on how we could correct these factors. The main aspects we're going to try to correct is the center of mass position relative to the start line, which would be implement changes to the block setup, where we would shift the center of mass of the participants closer to the starting line and ensure that their posture still remains optimal, with a straighter back and hips remaining the highest points in the ready state. Changes to the setup should also encourage better movement segmentation and prevent swing motion that we saw beforehand occurring again. We should be able to see a more fluid start that will assist in introducing the next biomechanical change, which is trunk inclination angle. After we can get the athlete more comfortable with performing a start, we could then start targeting him or make the athlete target getting the biomechanical range of 35 to 45 degrees. Again, as the literature said, that the optimal trunk angle exiting the block is around between 35 and 45 degrees. We should make sure that by improving our technical skill of the participant and ensuring that the block setup is better than what it used to be, we can ensure that the actual leaving of the blocks and the trunk angle when leaving that block can remain at that optimum range. And by improving the technical skill of the participants and ensuring that the range is met, we're gonna first exit the block quicker and also create greater ground reaction force and horizontal propulsion. Pretty much this means that we're gonna be producing greater force and maintaining negative correlation. And if we retain the negative correlation that we already have, it would result in greater displacement in the same amount of time. Thank you for watching. This is my references.